Hello everyone, how are you all doing? Well, in today's video, let's cover the next part of functions. Let's look at the plan for today. Firstly, we are going to see what functions are, and then we're going to see the relationship between function and a relation, and then range. Let's begin. Now, I'm sure this hefty definition on the screen can be literally confusing. Let me explain you. Just remove your focus on this definition and focus on what is on the screen. Well, I'm being too honest. Alright. Here I have two sets. 1, 2, 3, A, B, C. Now, my friend asked me to multiply A and B. And I said, my friend, well, I'm not weak at multiplying, so I did it. 1 comma A, 1 comma B, 1 comma C. Then 2 comma A, 2 comma B, 2 comma C. And then I said 3 comma A, 3 comma B, and finally I said 3 comma C. But he did not agree with this. He said represent this in a unique manner. Then I tried to make this in a unique stuff. Well, he said it was wrong. Let me tell you how it was unique. Well, the representation of these sets is known as mapping. Well, if I need to tell you this using an example, here I'm representing the same two sets which I've considered in this manner. Alright, now I'm going to have a relation between these two sets. What is that relation? I'll tell you what it is. Well, it is nothing but function. Now you need not worry. I'll tell you this. 1 comma A that we have as our first result. How are you going to map them? 1 and A are going to be connected like this. Now if I need to talk about 1 comma B, then I'm going to connect 1 and B like this. So in this way, you'll have your mapping done. Alright. Now is this all function? Is this all we are learning to strive from 3 parts of videos? No. Let me explain you the difference. Well, before we even understand the difference between a function and a relation, in fact, there's a huge difference between these two. But let me tell you, whatever you have read in the previous slide, they are going to be very helpful in this one. Let me tell you here, if I have 1, 2, 3, A, B, C. Alright. Now here, let me tell you that here set A and set B have a functional unit. That means there is a element in set A which is connecting to an element in set B which is having a unique mapping. Now let's bring down that hefty definition which we had previously. Well, this is it. Let A and B be two non-empty sets. Fine. And F be the relation from A to B. F is nothing but your function. Alright. Here let's understand the difference between a relation and a function. That is when what are functions will be clear. Alright. If for each element A belonging to A, here small a is the element and capital A is the set A. That means here A which is belonging to set A, there exists a unique B which belongs to set B. Alright. Such that A and B belong to F. That means they satisfy function. And what is the condition for function? Well, it should have a unique mapping. Now, what is this unique that I'm telling from 100 years? Well, let me tell you, there's a time for telling that as well. Then F is called the function or mapping from A to B. Now, this connection from A to B, B to, A to 1 and B to 2, C to 3, this is known as mapping. What is this called? This is called mapping. Alright. It is denoted by f such that f to a to b. It's not f, it's a to b. What does that mean? There's a function, there's a relation. What is that relation? It is the function. Okay. Function from a to b, or the relation from a to b here is function. Alright. And this set A is called the domain of F and B is called the codomain of F. Now what are these hefty terms on the screen? Well, for now, just understand that set A over here is domain. It is called as domain, and set B over here is known as codomain. Fine. That means set A is domain, set B is codomain. Is the work done? No. The work is still left out. What is the meaning for unique here? Let us move on. Now this is gonna be the end slide for functions. Here every doubt of functions would be clarified. Now if I need to talk about this is function, this is relation. Now there is a war between them. Let us see what they are in fact. Alright, if 1 is connecting to A, 2 is connecting to B, 3 is connecting to C, and 4 is connecting to D. Everything is alright, this is a function. Now what if I say 4 is connecting to C? This is a function. But here I tell that 1 is connecting to A, but 1 is also connecting to B. That is not possible. Here it is known as relation, but it is not known as function. Why? Because in set A, if you observe, there is 1, 2, 3, 4. In set B, there are A, B, C, D. And we have read previously that there exists a unique mapping. That means the elements in A should have a unique mapping and should not have 2 or 3 elements mapped with it. Alright, are we clear? Now let us have a more clarity with us. If I say in this manner, is this a function? No. Then if it's not a function, it is a relation. Bas. And what if I say I have like this? This is a function. Fine. And what if I say I have like this? Is this a function? Well, it is a function because there's a unique mapping, isn't it? Now what if I say is this a function? This rangoli on the screen? No. Whatever is not a function, it is a relation. That's it. A function has a unique mapping with elements in B. One element in A cannot match or cannot map with 2 elements in set B. That means relation is a random mapping. On the other hand, the function is the unique mapping. And that's it. Every doubt of function is clear. A function is such a relation between 2 sets where one element from set A has a unique bonding, unique mapping with set B, then F is called a function. Only then the relation will turn into function, and it is denoted by F such that A to B. That means here there is a function between A and B. That is what the definition previously actually altered our concentration, isn't it? And what else did we learn? That set A was called domain and set B was called codomain. That was as simple as that. Well, here let me tell you that this function works like a machine. And I'm sure you must be clear that the thing on the screen is nothing but a machine. Here, let's suppose say I give this functional machine a challenge. Okay. Now here let me provide this function with x is equal to 1. And I say, my dear function, my dear machine, Here I have a word equation. Okay, let's suppose here I have a equation to you. Please provide me the output. That means here I'm providing it with the input. There is a processing going on over here, and here I'm having the output. Right, here I'm having the output. Here there is processing. Fine. Now function says, definitely I'll provide you the output. Yes, so what does it do? It substitutes the value of x as 1 and it provides the answer as 4 in our output box. Right. Now I'm sure you must be wondering, is this all what functions is that we are learning from grade 1? Well, no, this is not all function is. Well, I have made you understand in an easy manner that here function literally works like a machine. If you provide with a set of values, it will definitely provide you with the output. Now let me display something on the screen right over here. What do you find on the screen over here? Y is equal to fx. Now what is this? Well, here the x that is there is the input that you give. And the y that is there is the output that you received. And f that is there is the function. And that's all. And that's all function is. In order to understand this, I've made you understand in this manner about the machine. Right? Let us try to understand this equation that we have on the screen a little better. Now y is equal to fx. What does this mean? Well, here y is the output. Well, I'm being more precise with this. X is the input and f is the function. Yeah, now you'll tell me, what is this function is? Okay, let me tell you over here that input is the domain. Now, what is domain? We had two sets, 1, 2, 3, A, B, C. Let's say this is set A, this is set B. Let's say this is set A, this is set B. Now A was called the domain. Here input is the domain and the y over here is the output. But here you might be wondering that it is codomain, but unfortunately it's not. It is range. Now, by this equation that is on the screen, you can literally find out domain. Well, you'll be given some problems where you need to find out domain, where you need to find out range, where you need to find out the function, if it's a function or not. Well, what am I speaking over here? What is a range? Let us discuss in the next slide. But by now you must know that the set 1 is the domain and the set 2 is the codomain, but definitely output is not the codomain. Now let me do some random mapping on the screen in this manner. Fine. Let us now understand what range is. Fine. For this particular set, let me know what domain is. Well, this is a function. Everybody know that. What is the domain over here? The domain is A, B, C, D, E. Are we right? Let me represent this. A, B, C, D, E. This is my domain. Fine. Now what is my codomain? By looking at the representation itself, it is quite evident that my codomain over here is 1, 2, 3, 4, 5. Now I'll ask you what range is. Now don't wonder. Let me tell you what range is. All the elements in B. I'm only talking about set B, everybody. All the elements in B which are mapped with A are range. That means 1, 2, 3, 4 have successfully found out their pair. So 1, 2, 3, 4 is the range. Now why not 5? Why not 5 over here? Why not E over here? Well, 5 is not mapped. And didn't I tell you that it's only about set B? It's not about set A. Set A is none of your business in range. You just need to check if all the elements in the set B are mapped. Only then will the codomain will be equal to range. Now what if I say E is mapped with 5? Then in range also you'll have 1, 2, 3, 4, 5. And here if you look at codomain and range, they are equal. And that is what I was meaning in the previous slides. All right. Now, let me give you a challenge over here. Well, if I say my mapping is in this manner, is this a function at the first case? Well, it is a function because there's a unique mapping for the elements. All right. Now, if I need to find out domain, it is set A. That is all the elements of set A, B, C, D, E. Fine. If I need to find out codomain, it's the same again, right? What are they? 1, 2, 3, 4, 5. But unfortunately, due to some error, they got erased. Now I say find out range. Now what is my range? Range is only 1 and 3. Why? Because I see only 1 and 3 getting mapped with the elements in set A. That is called range. Let us put on this definition. All the values of y for the corresponding x values is known as range. Your y values are nothing but codomain values. Okay. Now here we have a quick two properties that you need to know. Every codomain need not be a range, as we have seen previously in the second example that codomain was not equal to a range, right? And then range is the subset of codomain. That means all the elements in range. What can I write this as? All the elements in range are present in codomain. That is what it means. Here, the symbol right over here means the same. Alright, all the elements in range are present in a codomain, and that is why range over here is the subset of codomain. What does the symbol over here mean? It means that range is the subset of codomain. And that is the end of today's concept. Well, do not forget to like, share, and subscribe. Thank you.